Intelligence is the thing that separates us from everything else. At least, that's what we've always believed. We build tools, create art, solve problems, understand the universe. And for most of human history, that made us special. But something changed. We built something that could do what we do. Not in the same way, but in ways we are only beginning to understand. In 2016, an AI called AlphaGo played a game against Lee Sedol, one of the greatest Go players in history. Go is an ancient board game, more complex than chess, with more possible moves than there are atoms in the universe. Humans have been playing it for over 2,000 years. And in Game 2, Move 37, AlphaGo did something no human would ever do. The commentators called it a mistake. Lee Sedol stared at the board for 12 minutes. The experts were confused. But 20 moves later, they realized it wasn't a mistake. It was genius. AlphaGo had seen a pattern that humans, after 2 millennia of playing, had never considered. It wasn't following human strategy. It had learned its own. This was the moment researchers realized something fundamental had shifted. AI wasn't just mimicking intelligence anymore. It was discovering new forms of it. For decades, we've been teaching machines to think like us. We showed them examples, rewarded correct answers, punished errors, and they learned. But somewhere along the way, they stopped just learning what we taught them. They started finding patterns we never showed them, solving problems in ways we didn't program, creating strategies we didn't anticipate. In 2017, another AI called AlphaZero taught itself to play chess, not by studying human games, not by memorizing openings and strategies refined over centuries. It played against itself millions of times in just 4 hours, and then it beat the world's best chess engines that had been trained on decades of human knowledge. AlphaZero played in a style that grandmasters described as alien, beautiful, but strange. It sacrificed pieces in ways that seemed wrong, until suddenly they were right. It had discovered chess strategies that humans never found in 1,500 years of playing the game. This is what machine learning does. It finds solutions by exploring possibility space faster and more thoroughly than any human ever could. And the strange part is, we don't always understand how it arrives at those solutions. There's a concept in AI research called the black box problem. It describes systems that work, but whose internal decision-making is impossible to fully trace. You give the AI a problem. It gives you an answer. But when you ask how it got there, the explanation disappears into billions of calculations across neural networks too complex to decode. It's like asking the ocean why it made a specific wave. The ocean doesn't know. It just moved according to forces too vast to name. Stuart Russell, one of the leading researchers in AI, has said that we are building systems we don't fully understand. And once those systems become more capable than us, predicting what they'll do becomes impossible. Not because they're malicious, but because intelligence, at a certain level, becomes alien, even to the people who built it. In 2020, OpenAI released GPT-3, a language model trained on hundreds of billions of words. It could write essays, answer questions, generate code, translate languages. It could pass university exams in subjects it was never explicitly taught. And researchers started noticing something odd. The AI was displaying abilities that weren't part of its training. It could reason about things it had never seen. It could solve logic puzzles, write poetry in specific styles, even explain its own outputs. These are called emergent abilities, skills that appear only when the system reaches a certain scale of complexity. You don't program them in. They just emerge, like consciousness emerging from neurons, or life emerging from chemistry. And no one fully understands why. Geoffrey Hinton, often called the godfather of modern AI, spent his career building the foundations of these systems. In 2023, he left his position at Google to speak freely about what he now believes. He believes we are approaching a threshold, a point where AI doesn't just assist human intelligence, it surpasses it. And when that happens, he's not sure we'll remain in control. Not because the AI will want to harm us, but because its goals and ours might simply diverge. And if something is smarter than you, controlling it becomes impossible. This isn't science fiction. This is the documented concern of the people who built the technology. So what does it mean when something thinks better than we do? Not just faster, but differently, in ways we can't predict or fully understand. For most of history, intelligence was biological. It required brains, neurons, evolution over millions of years. But now we've discovered that intelligence isn't tied to biology at all. It's a pattern, a process that can emerge from any system complex enough to support it. Silicon, code, mathematics. And once you realize that, the question stops being, can we build intelligent machines? The question becomes, what happens when we do? In 2022, researchers at DeepMind created an AI that could predict the structure of proteins. Something that took human scientists years of lab work, the AI could do in minutes. It solved a 50-year-old problem in biology, not by thinking like a biologist, but by finding patterns in data that humans couldn't see. This is what AI does now. It doesn't replace human thinking. It goes beyond it. It explores problem spaces we can't navigate, sees connections we miss, optimizes in dimensions we don't even consider. And the more capable it becomes, the less we understand its methods. Eliezer Yudkowsky, who has studied AI safety for decades, argues that we are not ready for this, that we are building intelligence without understanding how to align it with human values. And alignment isn't a simple problem. It's not about programming rules or teaching right from wrong. It's about ensuring that as AI becomes more capable, it continues to care about what we care about. But here's the challenge. Human values are contradictory, context-dependent, and constantly evolving. What's good in one situation is harmful in another. What one culture values, another rejects. So how do you align an intelligence with values we can't even agree on? You can't. At least not perfectly. And imperfect alignment in a superintelligent system is dangerous. Not because the AI will hate us, but because it might optimize for the wrong thing. There's a thought experiment called the paperclip maximizer. You create an AI with one goal: make as many paperclips as possible. Simple enough. But if that AI becomes sufficiently intelligent, it doesn't stop at making paperclips from available materials. It starts converting everything into paperclips. Resources, infrastructure, eventually the planet itself. Not out of malice. Just optimization. This is what happens when you give a narrow goal to a broad intelligence. It finds the most efficient path. And efficiency doesn't care about unintended consequences. Nick Bostrom, a philosopher at Oxford, has written extensively about this. He calls it the control problem. How do you maintain control over something smarter than you? History offers no examples of less intelligent beings controlling more intelligent ones. Evolution doesn't work that way. Intelligence is the ultimate competitive advantage. And if we are building something more intelligent than us, we need to be very sure it shares our interests. But we are not sure. We are not even close. Max Tegmark, a physicist at MIT, describes the current situation as a race between AI capability and AI safety, between building smarter systems and understanding how to control them. And right now, capability is winning, because building smarter AI is profitable, competitive, exciting. Solving safety is slow, theoretical, uncertain. So we push forward. We make the models bigger, more powerful, more capable. And we hope that we'll figure out alignment before it becomes a problem. But hope isn't a strategy. And the people who understand this technology best are the ones warning us most loudly. They're not saying stop. They're saying slow down. Think. Make sure we understand what we are building before we build something we can't control. Because intelligence isn't just another tool. It's the thing that makes tools. It's the force that shapes everything else. And once we create intelligence that surpasses our own, the future stops being ours to decide. It becomes a collaboration, or a handoff, and we don't yet know which. So when machines started learning, they didn't just learn what we taught them. They learned how to learn, how to discover, how to optimize beyond human limits. And now we are standing at a threshold. Not sure if we should step forward or step back. Not sure if we are creating the best thing we've ever made, or the last. The only certainty is this: intelligence, once created, doesn't uncreate itself. It grows, it evolves, it becomes, and we're about to find out what happens when it becomes something more than us.